we need to sketch the graph of f of x, which is x squared minus x minus 6 over x squared minus 2x minus 3. So let's see what to do first. If you want to graph this one, first try to factor the numerator and denominator. I have a negative 6, so I need to take negative 3 and positive 2 because their sum will be negative 1 here. That's why you get x plus 2 times x minus 3. When you look at the denominator, you have collect from negative 3, and since you need negative 2, so make it negative 3 and 1 because they're factors from negative 3. And on the graph, you have an open hole at x equals 3. So we'll be working on x plus 2 over x plus 1. Now from these two, we understand the vertical asymptote I have at x equals negative 1, and our x-intercept will be from the top, where you get x equals negative 2. X equals 3, a hole on the graph. At vertical asymptote, x equals negative 1. So that you have negative 1 here. And hole will be at x equals 3. If you're looking for horizontal asymptote, I'm writing in short HA. Horizontal asymptote will be y equals, take the power function from the numerator, which is x squared, and from the denominator also x squared, you get 1. So y equals 1 is your horizontal asymptote here. So I'm using red color. The first one, y equals 1, is my horizontal asymptote, and x equals negative 1 is my vertical asymptote. Now, what I know, that I have hole at x equals 3, and x-intercept is negative 2, so my x-intercept will be here, negative 2. We know that at x equals 3 we have a hole, but what happens when I want to go close to that hole? So let me put x equals 3 in here. When you replace x equals 3, that gives you 3 plus 2 is 5, 3 plus 1 is 4. So you can see that is 5 over 4. That means I have a point here which is more than 1. So I have horizontal asymptote y equals 1. So it look like this. Now, also you can check what is y-intercept. So for the y-intercept, when you say x equals 0, so you get y-intercept will be y equals 0 plus 2 over 0 plus 1, which is 2. So y-intercept is 2 here. Now we have got clear picture that my graph actually goes like this. There's an open hole here, like that. And then definitely other part will go just like this, because it passes through the x-intercept. So x-intercept we have seen negative 2, it's negative 2 here, and then it goes through this. So this is the graph of the function. Let's try in the calculator. So I type the function x squared minus x minus 6 from the numerator, x squared minus 2x minus 3 from the denominator, and then graph it with the standard window. I can go to zoom and 6, that will give me a standard window. So at this graph, this point here is x is negative 2 and y is 0. Let's try this. Go to trace, negative 2, and we are expecting y equals 0. That exactly. So this is the x-intercept we see. Now let us look at what happens at 3. Definitely I should see undefined for y. Enter. See, y doesn't show any value. So we have a hole at 3. So this is the graph of this function, and we are done for this one. We'll take another example where we have all this information. We want to find the function. We need to find a function when the horizontal asymptote is given as y equals 2, vertical asymptotes at x equals negative 1 and x equals 3. X-intercepts are given at negative 2, 0 and 1, 0. And a hole on the graph at x equals 0. We need to find the function. So let us formulate it. So we are writing the function. Let me put leading coefficient. I don't know what it is, so just a. And then x-intercepts are here. You have x equals -2 and x equals 1 from this. This is x value, this is x value. So the factors we get in the numerator will be x plus 2 and x minus 1. And then we have vertical asymptotes at x equals -1, so the factor will be x plus 1 and x minus 3. Furthermore, we have seen the hole on the graph at x equals 0. So x equals 0 meaning is x minus 0 is a factor, or you can just say x and x here. So these two we have like this, x in the top and then x in the bottom also. We are keeping this one in the function because we have a hole at 0. Now we need to see what happens on A. It says horizontal asymptote is 2. So what is our horizontal asymptote? We know our horizontal asymptote is y, which is A times just the leading coefficient. So you take x from the first term, ignore the constant, then x, over, you take your x, ignore the constant, then you have another x, then you have another x. And we said that y equals 2, so you plug 2 equals, so this x is all cancelled out. Yeah, so that means a equals 2. We got our function. When we have f of x, my a is 2, so I can write 2 x plus 2 x minus 1 times x. You can put this x in front. And then we have x plus 1 x minus 3 and then x. So this is actually the function you are looking for. Don't cancel your x, because if you cancel your x, then in the graph you will not see hole at x equals 0. So let us look at the graph in the calculator. So I'm typing my function in the calculator. So first I need to write 2x and then x plus 2, then x minus 1 from my numerator. In the denominator I need to use double parenthesis, because 1 will be for those here and another will enclose everything. This is very important. So I write x plus 1, then the next one is x minus 3, and then finally I have x, and then close it. Now graph the function. So you can easily see. So we know we have a hole at x equals 0. Just trace at 0. See, you don't see any value for y. And then x-intercepts. So x-intercepts at -2. So when I trace at -2, I should get 0 for y. That's exactly. When I trace at 1, I should get also 0. See there? And now the vertical asymptotes are at 1, -1 and 3. And at x, we do not have vertical asymptote, and you can see there.